Hello and welcome to our lesson 1.2, flipping Ferraris. Okay, so my name is Mr. Pena. I am going to be taking you through some of these solutions today. So we have a couple of problems to get through. I'll try my best to explain as much as possible. Some of these might require more work than others, so I'll try to be concise and clean with that. So let's get right into it. So, question one, solve for x. So, again, you want to isolate your variables and have x by itself, right? So, to do that, I would move 2, subtract 2. So, I get 15 is 5x. So, now I have that 15 is equal to 5x. To get rid of this 5x and have x by itself, to isolate it, I divide both sides by 5, right? What I do to one side, I do to the other. And I get that 3 is equal to x. That would be my first solution right here, right? To double check your work, you can clearly directly plug it back in. Plus 2. So 5 times 3 is 15. Plus 2 is equal to 17, which equals just a true statement, right? That's kind of what I wanted to see from the very beginning. I wanted to see 17 here. Great. The next one, let's move everything to one side, right? So I want to move minus 2x squared here, and then move it up here, okay? And then I want to do let's do a different color here. So we'll do a plus 5 and combine it to this plus 5, okay? So then I'm going to get 3x squared minus 2x squared. That gives us just x squared. This stays there, minus 12x. And then 31 plus 5 is equal to plus 36. Okay? Now all this is equal to 0, right? Because what I did is that I moved all of this over here. And I combined all those terms. Okay? Now I want to solve for this. You can do quadratic formula, which I don't think we'll need for this particular problem. You can do factoring, which I think that's kind of what I will do. Factoring. Okay, so let's factor this into a product of two binomials. So I get x, right? I want to have a positive, but I have to have a negative. So this has to be minus and minus. Now I need to think about what numbers multiply to 36, but add up to technically negative 12, right? So I see that 6 and 6 would work for me, okay? Double check that, I get that this is x squared minus 6x minus 6x plus 36, x squared minus 12x plus 36, okay? So this is essentially correct. Now I set every single one of these right here. I'm going to set them equal to 0. So x minus 6 is equal to 0. And what do I end up getting when I do that? Right? Again, this goes back to problem number 1, solving for x. I add 6 to both sides, and I get that x is equal to 6. Okay? So let's go. Cool. Now our number 3, I have a square root function in there, right? So we're not gonna get scared. We're gonna get rid of the square root. Okay? To get rid of a square root, I have to take it to the power of 2. Okay? So I square both sides. So to get rid of a square root, you have to square both sides. Okay? What you do to one side, you do to the other. It's like one of those math properties. Okay? So 11 squared is 121 equals, what's going to happen here? Well, this square root and this power of 2, technically, well, not technically, but they cancel each other out, right? So I get left with 2x plus 1, and I kind of just go ahead and solve now, right? So goes back to problem number 1. Minus 1, oops, minus 1 on both sides, so I get 120 is equal to 2x, and then dividing this by 2 divided by 2, I get that 60 is equal to x. So that's my third solution, okay? Now, number 4. So very, very similar here, right? What did I say earlier? If I have a square root, if I have square root of a big number inside a block, we'll call it a block, equals 2. So, again, if you have a square root, so I'll make it here. So if you have a square root, you want to square it, okay? So it's like square root of x squared, okay? You square it to get rid of the square root. To get rid of square root. I'll just call this square root, okay? So let's go back. And if I have on both sides, I'm going to square both sides, okay? So again, the square root kind of goes away, right? So I get x squared plus x minus 2 is equal to 2 times 2 is 4. And now I want to go ahead and do something very similar to what I did in question 2, right? So now we're making those connections. So I'm going to go ahead and subtract 4. I want to move everything to one side, right? Minus 4. So I get that this becomes x squared plus x minus 2, negative 2, minus 4, right? So I have two bad guys, and I'm subtracting 4 good guys, right? So I'm going to get more negative. 6 is equal to 0. Okay, negative 2 minus 4 is equal to negative 6. Okay, careful there. Now I have this trinomial here. Well, yeah, and then let's factor this out, right? So I have x, and I need to have a plus and a minus because this is a negative, and I need to think about numbers that add up to 1 but multiply to 6. So I can think about 1 and 6, 2 and 3. That's about it, right? So I need to have the positive one has to be the greater number. So x plus 3 times x minus 2 equals 0. Okay, so those are the way I would set that up. And then I'm going to go ahead and set all of these, each of them equal to 0. So x plus 3 is equal to 0. So then I get that x is equal to negative 3. And I'm going to get x minus 2 equals 0. X is equal to 2. And why am I doing this? Why am I setting them equal to 0, right? Well, if I know that this is 0, 0 times any number, a block, we'll call this a block, will be equal to 0, okay? So that's kind of the process and like the intention of setting them equal to 0. Because you know that if you set one of them equal to 0, then the entire thing will become 0. Cool. Okay, number 5, we have a little difference, right? So what do we see different? Okay, so we should see this 3 here, right? So what does that mean for us? That means that it's a cubic root, okay? Not a square root, so we can pretend that there's an imaginary 2 here, okay? This is a cubed root. So, again, I don't like square roots. You need to get rid of the square root to solve for x. How am I going to do that? This is a cubic root, okay? So similar, instead of taking it to the second power, I'm going to take it to the power of 3. Good. What I do to one side, I do to the other. Okay, so negative 4 to the third power. So it's negative 4 times negative 4 times negative 4. This right here is positive 16 times negative 4 will become negative 64. Okay, you have to be really careful there with the negatives. Negative, negative, make a positive, but then the positive times the negative, make a negative. Okay? So now I'm left with negative 64 is equal to 5x plus 1. Right? This kind of square root kind of goes away essentially. Now it becomes a really simple problem. We just keep on isolating x. So I subtract minus 1. So I get negative 65 is equal to 5x. Okay? Now, once I'm there, negative 65 is equal to 5x. Very, very similar to how we started doing this. To solve this, I divide both sides by 5. Okay? Negative 13, I'll make this more clear, is equal to x. Okay? Now, you should be able to plug in all these numbers back in to double check your work, okay? And I encourage you to do that. Number 6. So for number 6, we have a cube root, and then we have another cube root. So cube root of 352 equals cube root of 7x squared plus 9. And I think what's going to happen here is that we can go ahead and cube both sides, right? So that's going to get rid of it. So essentially, you only care about this inside part. So you would set these two equal to each other, okay? So you have 352 equals 7x squared plus 9. Now, sometimes you might want to move this, right? So moving this over here to this side, but that essentially won't really help us, okay? Because I want to solve for x by itself. So x here is almost isolated by itself. So let's do minus 9. So now I'm left with 343 is equal to 7x squared, okay? I'm going to divide by 7. So 343 into 7, let's do that. 7 times 4 goes 28 times, sorry, 28. Let's subtract here. So then we get 60, well 6, bring down to 3, 63. So that's 9 times, okay? Now we know that if I divide this by 7, I get that 49 is equal to x squared. Now, how do I get rid of that? So instead of squaring it, I'm going to take the square root. So I'm going to take the square root of this, okay? Because to cancel out an x squared, the square root of x squared is equal to x, okay? Plus and minus x. So right here, we'll bring a plus and minus, okay? Plus and minus 7 is equal to x. Now, this is important. You always need to bring in that plus and minus. Why? Because if I have 7 squared, that is equal to 49. 49, okay? Now, if I have negative 7 squared is equal to negative 7 times negative 7, which is equal to 49. So both of them are solutions, okay? So you need to make sure you talk about both the plus and the minus 7. Okay, we're making some progress here. Number 7. So this is a exponential equation, right? So I have 3x equals 243. Okay, so we haven't covered logs yet, right? We're gonna have a fun time with that soon. But for now, I wanna rewrite this 243 as a power of 3, okay? So now I get 3 to the x is equal to 3. Same base to this magic number, okay? So what number is going to be there, okay? So I actually don't think it's, well, it's important to memorize your powers, but this one's a little bit high. So 3 squared is 9, 3 cubed is 27, 3 to the power of 4 would be 81. This is 81. And then 3 to the power of 5 is, ding, 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 243, right? So the important number here is that this is 5. So we rewrote this to the power of 5, okay? And I'm solving for x. So the bases are the same. The thing we care about is the exponent. So then we go and say that x is equal to 5. This is our solution here, okay? Now, number 8, okay, very, very similar. So let's think about our powers of 5. So if I have 5 to the 0 is 1, 5 to the power of 1 is 5, 5 squared is 25, and 5 cubed is 125, ding, ding, ding. Okay, I can keep on going. I don't need to, right? So let's rewrite this as 5 to the x is equal to 1 over 5 cubed. Okay. Now, there is some rules that I'm going to assume that you know some of these rules, right, as to how to rewrite this. So let's kind of, I'll put this over here. Okay, let's kind of talk about rewriting this. 5 to the x is equal to 5 to the negative 3, okay? Because if I have 1 over, I'm going to say, if I have like x to the negative a, that is equal to 1 over x to the a, okay? This is one of those properties. So right here, I rewrote this as 5 to the negative 3. So then I get that x is simply equal to negative 3. Okay, that's number 8. Number 9. Okay, so my first instinct would be to write my powers of 4. This is 1, this is 4. 4 squared is 16. 4 to the cubed is 64. So we run into an issue there. And I hope you can pick up on what the issue is that we already passed it. Like you know what I mean? Like this is 1664. What I was doing here was finding the exact one. Like here it was 5 cubed, which was 125, and this was 243, right? But this is not helpful because this didn't help us at all. So we need to think a little bit more, okay? So now let's rewrite this 4 as a power of 2, okay? So let's think about this as 2 squared to the power of x is equal. And now let's kind of think about 32 to the powers of 2 now. So if I have 2 to the 0 is 1, 2 just 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, almost, 2 to the 5 is 32, ding, ding, ding. Okay, so I found that. I can rewrite this as 1 over 2 to the 5th power, okay? Now, we're getting there, right? So now let's go back and think about this other property we talked about, that I can rewrite 2 squared x is equal to 2 to the negative 5, okay? Now the last kind of step we need to think about, I'll move this a little bit over here, is that, what is this? So when I'm taking a power, I can multiply my exponents, right? So when I multiply exponents, I add them. When I'm dividing them, I subtract them. And in this case, I am taking into the power, so I'm multiplying. So I get left with 2 to the power of 2x is equal to 2 to the negative 5. Now what I need to do is I need to set my exponents equal to each other. So I get that this is 2x is equal to negative 5, and x is equal to negative 5 over 2. So that is my answer for this. Okay? This one required a little bit more work and a little bit more thinking as well. Let's jump into question 10. So it says that students were given a set of data to graph. After they had completed their graphs, all students shared their graphs with their partners. When Ethan and Emma saw each other's graphs, they exclaimed together, "Your graph is wrong. Neither graph is wrong." Okay, neither graph is wrong, so that's important to note. Explain what Ethan and Emma have done with their data. Okay, so I'm kind of just gonna connect the dots here because that's kind of my first thought of doing. Cool. Um, Now we kind of have to think about what are these points? Like, let's kind of find good points to talk about. So this point right here is 4, comma 2. I kind of like this point here too. This is just 1, comma 1. And then let's talk a little bit about another one. Let's call this one 2.1, comma 1.5. Okay. Now I'm going to do the same thing over here. So here I have 1, comma 1. And I have 2, comma 4. And then I have 1.5, comma 2.1. So I hope you picked up on the fact that what happened here is that the domain and range are switched, right? So someone, and I don't, maybe the graph is wrong. So technically, like, yeah, um, when they plotted their points, they plot them backwards, right? So we see that there's a 4, 2 here, and there's a 2, 4. So their points are flip-flopped, right? So points are flip-flopped, okay? Now I hope you can pick up on this, is that when their points are flip-flopped, that essentially means that they are inverses of each other. So they are inverses, okay? And now it's important to kind of make that connection that an inverse function is a reflection over the line. So inverse is a reflection over the line y equals x. Okay, so essentially all you need to do is reflect over the line y equals x. Okay, so let's kind of think about, well, I'm not really going to do that. Let's just kind of think about color here. Let's see if that's gonna even help us visualize this. Okay. Not really the best graph, I would say. It's okay. Okay, I hope that kind of made some sense. This is part of the set problems. Let's talk about 12. A baseball is hit upward from a height of 3 feet with an initial velocity of 80 feet per second. Okay. The graph shows the height of the ball at any given second during its flight. Okay. So without talking about any of the questions yet, let's talk about what we see. What are we seeing here? Okay. This is the baseball. It was hit upward. So this is the baseball. This is a baseball. Baseball. So think about this. There's a person batting. The ball obviously goes up to a certain point, and then it goes down, right? So the ball goes up, reaches the max, and then it comes down. Okay. So this is, again, you should kind of recognize this shape. This is a parabola. How do you spell that? Parabola, right? Okay, cool. Approximate the time that the ball is at a maximum height. Okay, so the maximum height happens right above here, right? So there's a, let's make this a little bit, let's pretend that it's perfect. Okay, anyways, it's right here, right? That is essentially the maximum height. And they want us to approximate it in seconds, okay? So I would say that that's pretty much about 2.5 seconds, right? So let's make this a note here. This is 2.5. So the ball is at its maximum height at about 2.5 seconds. Okay? Approximately the time the ball hits the ground. So when does this ball hit the ground? So it's gonna go up. So we are up, 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 up. We reach the top, and then we're gonna come down, 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 down to the ground, right? So essentially, this happens at about 5 seconds, I would say. Um, yeah, it's asking for an approximation. So approximate the time the ball hits the ground. So the ball approximately hits the ground at 5 seconds. Maybe a little bit more than 5 seconds. Like we can just do like about 5.05 seconds if we want to be a little bit specific. And the reason being is that at 5, you actually hit 3 feet. So it needs to be a little bit further down, right? So let's just do 5.05 seconds, okay? Part C. At what time is the ball 67 feet above the ground? So we're looking for 67. So this is 60. This right here is 70. Okay, so this is 70. So 67 is essentially going to be, oh, there's a mark here, right? 67. Um, so we see that there's going to be about 2 times where the ball is 67, right? So there's 67 is here. So there's one there and one there. So let's say that this is going to be at 1 second and then again at 4 seconds, right? So I would say that the ball is at 1 and 4 seconds. It's not say, okay, cool. Make a new graph that shows the time when the ball is at the given height. So now I have my height and I have my time in seconds. Okay. So my graph will look a little bit different, right? So if I have my height in feet, so let's kind of go with same things. You have 20, 40, 60, 80. We can do 20, 40, 60, 80, and 100. Let's kind of think about those. And then let's make this graph. So at 1 second, we are at 67 feet, right? So my times, let's do, honestly, this is up to you to scale it as best as you can. I'm gonna try my best to just do 1, 2, 3, 4, 1, 2, 3, 4, and then 5 right here. I'll move these closer away to them so far. Perfect. Cool. So at 1 second, so the height at 1 second was 67 feet. So then at 1 second, we are essentially close to 67. So I'll put a mark, I'll make a dot right here. This is 70, 67. Right here, we'll do that. And then let's see another point at 4 seconds. We're also at 67, so I'm gonna make a point right there. What else do we see? What else? What else? What are some other good points? So at 2 and at 3. So at 2, we are at 99. And then at 3, we're also at 99. So then let's talk about that at 99 feet, we're at 2 seconds. So essentially going to be right there. And then at 3, we're also going to be right there. Okay. Now let's think about some of these points over here. So at 5 seconds, we are basically at the ground. So at 5 seconds, we are, let's just call it 0. And then at 0 seconds, we're about 3 feet. So let's call this basically going to be right there. Okay, so I'm going to connect some of these dots, and I hope you can kind of see the shape already. And I'm not the best person at connecting dots. I can't connect the dots so well. but it's something like that. Okay. This is what it would look like. So the new graph is the inverse of the height, right? And that should be a little bit more clear now, because before, I'll make this nicer. So before I had my time, comma, height. Okay. Now my after, I flipped them. Now I have height and I have time. Right? So I flipped those. So that is the inverse. Okay. This is the inverse of the time versus height graph. But it is not a function. Okay. How would you restrict the domain on the original function to make it invertible? So it is not a function because it does not pass the vertical line test. Okay, so it doesn't pass the vertical line test, right? So there you go, doesn't pass it. Okay, so to restrict the domain from the original function to make it invertible, you can essentially see that I would have to cut it at the halfway mark. Oops, I would cut it here. Okay, so very similar to it here, I would cut it there. So my restricted domain to 0, 2.5 will make it an inverse function. I think another possible answer that I think would also be fair is that if you were to restrict it from 2.5 to 5, you can also restrict it from 2.5 to 5. Okay. Now, for the good part, are Go problems. Go, go, go. Okay. So we're gonna use these to, the functions are defined. So I have three little functions, right? And I want to calculate the indicated function values. So I'm gonna put these right here at the very top so I can see them. Perfect. Okay. So these are functions, okay? There's f of x, g of x, h of x. So these are three different functions, okay? This is telling me that it's f of 7. So f of 7 is equal to, I'm going to plug this into f of, well, this 7 is my x here, right? So this becomes 3 times 7, which is equal to 21. 21? Okay. Now I have a negative 9. So add negative 9 is equal to 3. 3 times negative 9 is equal to negative 27. Okay. Now, 15. What is that? I have a variable. I don't have a number. What do I do, Mr. Peña? Okay. You don't freak out. You don't get scared. Okay. So, just the way we've been plugging in a value in for this, for x, we're going to plug in 3 times s. Okay. Now ask yourself, 3 times s. 3 times s is equal to 3s. Okay. That's it. That is it. Okay. 3s. Very good. I'll make this more clear. My 3's are horrible and my s's are horrible, so I apologize. 3s. Great. Cool. Now, even more confused now, right? I have an s minus t. So what does that mean? So this is equal to 3 times, right? This replaces my x. Think about this as your x. So this becomes 3s minus t. I'd take this answer perfectly valid, or you can distribute it out and have 3s minus 3t. Okay, no need to do that. You can leave your answer like that, totally valid for me. This 35, this is fine. Okay, now we're talking about g. So I'm gonna essentially paste this again because I already forgot them, right? And let's think about g of 7. So now I'm not going to plug it into f because I don't need that, right? I'm talking about function g. So I don't care about h either right now. I care about g. So this is equal to 10 times 7, right? Plus 4. This is 70 plus 4 is equal to 74. Very nice, right? This is a plus. So I am plugging in this 7 into this x, right? This is x right here. We're carrying it out. Next one would be 10 times negative 9 plus 4, negative 90 plus 4 is negative 86, okay? You should be comfortable doing these calculations without your calculator, okay? You should not be using it. Now, s, we're into that problem again. What does s mean? Okay, think about this as your x value, okay? It's not a number, but it's a variable, okay? So 10 times s plus 4. What do we get? What's 10 times s? 10s plus 4, okay? That's it. So we have 74 here, we have negative 86, we have 10s plus 4. Now, this entire thing, this is still my x value. So wherever I see x, I replace it with my s minus t. So I get 10 s minus t plus 4. Now, I think it's important to further simplify this just to see it nicer. So I get this is 10s minus 10t plus 4. Okay. Ooh, now we're talking about h. Okay, so now we care about h. So we're talking about h now. I don't care about f. I don't care about g, right? All these are h's. Okay, so I only care about h. Now, let's do some algebra now. Let's get into it. So I'm gonna maybe put these up here. Okay. So h of 7. I'm gonna plug in 7 into x's. Okay. 7 squared is going to be 49 minus 7. This is 42. So take a moment. Let that sink in. Okay. This is not any different from what we've done. The only thing that changed now is my function. My function is now x squared minus x, okay? I don't plug it into f or g because this is a function of h, okay? Let's do 22. So I get that this is negative 9 squared minus negative 9. So be careful there, right? Parentheses are important. I'm subtracting a minus, parentheses, my negative 9, okay? Negative 9 times negative 9 is positive 81. And then right here, a minus negative 9 means I can combine these. So I'm left with 90. Okay, so 22 is 90. 42, 90. Okay, now h of s. Same concept. This is s squared minus s. Okay, it's equal to just s squared minus s. Okay, that's all you can do. You can maybe, I don't think I'm going to be, I would ask you for that. You can factor this out as s minus 1. Okay, both of them are acceptable answers. Equals. Okay, now 24. So now this entire thing is still my x value, right? Think about that, still my x. So this is equal to s minus t squared, okay, minus s minus t. This is my x, okay? These are my x values, x, okay? Now, let's go ahead and simplify this. We need to do that. Let's FOIL this out. Let's expand it. So let's do this on the side because this is crucial. S minus t times S minus t. Okay? Okay. I have to FOIL. Okay? Or just think about this as distributing. So this first one goes to this first one. S times S is S squared. And I'm left with S times negative t. I'll make this, let's do this a different color. And I get that this is negative st. And then let's do this negative t. This is negative t times s minus ts or st. Let's do ts, just Taylor Swift. Plus, let's do this a different color. And let's do negative t times negative t, right? So negative t times negative t becomes a plus t squared, okay? That's important. It's a plus t squared because t times t is t squared, okay? Now, this is just this part, okay? So I'm gonna essentially combine some of these terms. This is s squared. I'll do it back to a different color. This is going to be s squared minus, this is a t, so minus 2 st or ts, right? Same concept, plus t squared. So I'm going to replace this with s squared minus 2 st plus t squared minus s minus t. I can't really combine anything else anymore, right? There's nothing I can combine. This is s squared minus 2 st plus t squared minus s plus t. Okay. All I'm doing here is making sure that I am distributing this minus to both of them, this negative, okay? So my final answer is this long kind of expression or equation, okay? Let's paste this again up here now, okay? We're getting close to the end. Notice the function f of g of x is indicating that you replace x and f of x with g of x, okay? So let's kind of do this in a bigger scale. So 25, it's f of g of x, okay, is equal to. So you have to think about this entire thing as it being your x, okay? So I'm going to say that this is going to be 3 times g of x. X, my g of x function is 10x plus 4. This is g of x, okay? Now let's combine those terms. So I get that this is equal to 30x plus 12, okay? I distributed this out to both sides. 30x plus 12, okay? That's 25. Let's do 26 now. So 26 is f of h of x. So this right here is my x variable, okay? The entire function h is my x variable, okay? This entire thing, this whole concept, this whole equation, that is my x, okay? So I'm left with, I'll keep this as 3 of h of x. So then let's do a different color. Let's call this, well, not let's call it, but x squared minus x, okay? Now I can distribute this out, and I'm left with 3x squared minus 3x. Very nice, okay? This is my final answer. Last but not least, 27. I get g of f of x is equal. Okay, so same concept. This entire thing, this entire function is my x variable, but now I'm replacing it to my g function. So g was, let's do g of x is equal to 10x plus 4. Okay, this is equal to 10. For my x value, I'm putting in the function f of x. That's 3x plus 4. And then I just finish it off, okay? And let's actually, I'm going to put this color in pink just so we can kind of see the difference that this is my f function, 3x. Okay? And then at the end of that, I get this is 30x plus 4. Good. Okay. So I hope we kind of enjoyed that. There was a lot to do, and I hope that all of that kind of made some sense. Especially the first Redis problems and then like the Go problems. Okay, we want to make sure we are comfortable plugging in and kind of working with all different types of functions and being able to do this function composition. Okay, let's make this is a composition function.